So we looked at circles in a previous video. I still have a circle on my screen because I want to highlight what an ellipse looks like. And so with a circle, we have an x squared term and we have a y squared term. Can't have division by anything. They can't be subtracted from one another. They have to be added. So if I want to make an ellipse, I'm actually going to have to factor in division. And so let's say I'm going to have x squared plus 16. I'm going to have y squared, divided by 16. Let's say this is 9, and it equals 1. So with an ellipse, there are some very specific requirements the equation must have. You must have an x squared and a y squared. The terms have to be added together, and it's going to need to equal the radius, and the radius here isn't always the radius, but it's going to have to equal a number. Now, if you look at the shape of an ellipse, I want you to think of an ellipse like an egg. A circle has perfect round symmetry, whereas an ellipse has these corner points that would be like an egg. So this would be like a sideways egg. This sideways egg is going to correspond to very specific things in the equation. And so if I'm looking at this, I see that on my x-axis, I'm hanging out here at -8, which is interesting. And if I look at, if I have that one, I think I had 4 there. So I'm hanging out here at -8, and here I'm at 6. So at first, that could seem a little odd because why is that at -8 and why is that at 6? And that has to do with the major and the minor axis. So that's going to be dictated by these values right here that are underneath the conic section. Sometimes we get this confused with a hyperbola, and in a hyperbola, the difference is that there would be subtraction and it would have to equal to 1. And so that's kind of the difference in a hyperbola and an ellipse, is that an ellipse would be added, and a hyperbola, one of those terms would be negative. And so I'm going to take this down to a unit ellipse just so we can take a minute and see what it looks like. So here I have my nice unit ellipse. It's equal to 1. What we tend to want with an ellipse is we tend to want this to be equal to 1. Otherwise, we can't graph it well. So if this was equal to something else, I would try to divide all the terms by it, but I'll get to that in a second. So I'm actually going to hide this circle from our view right now. So now if I'm looking at this unit ellipse, things might be a little more clear. If I'm looking at this as points on the x-axis, you'll notice the square root of 16 is 4, and the ellipse touches the x-axis at +4 and -4. And that is in fact on purpose. If you look at the y, the square root of 9 is 3, and it touches the y-axis at 3 and -3. So if I want to graph an ellipse, all I'm doing is looking at the square roots of common numbers. So here in my ellipse, if I take the square root of 25, I'm at -5 and +5. If I take the square root of 36, I'm at 6 and -6. So when we're sketching an ellipse, the key is to be able to have it equal to 1. Now, just like we did with the circle, I'm going to shift it, but I'm going to keep that original ellipse on screen because that's really important for us to be able to understand it. Now, if I look at this ellipse, it's the green one is my new one. So here I added 2 to my x value, and it went from -5 to -7. So what we can say is if I was trying to graph this ellipse, I would ignore the 2 and I would draw the red ellipse myself because I can take the square root of 25 and the square root of 36. Then I would make a second drawing where I shifted every point to the right by 2 values. So if you're looking at all of these values, they're shifting, to the left by 2. Now what happens on the y? Let's see what y does. If I look at my y-axis and I subtract 1 and I'm looking at my ellipse, it's actually going up 1. So this is very similar to what we saw in the circle, but it's really hard to graph this equation without first graphing this one. It's much easier to ignore the values being added or subtracted, to just draw it using the square roots and then to move your 4 points. So I would move my 4 points to these new coordinates and I would connect the dots, and that is how you graph an ellipse. Now, what do I do if I'm graphing an ellipse and the book gives me something like, let's say, this? This looks like this is a circle, so I have it equal to 16. Notice that I don't have division happening here, so I don't have something that's creating an ellipse. So I wouldn't need to divide everything by 16 to try and make this look like an ellipse because it's a circle. Now, if I had something like subtraction in place, that's going to be a totally different shape, and we're going to visit that shape in the next video. But if I'm looking at this is my circle. If I want to create an ellipse, I'm going to have to divide these by something, and then that's going to be what generates my ellipse. And so there is ellipses and circles.